Hi, today we are going to do the calibration of the displacement sensor for the LoadTrac 2 unit. The displacement sensor is underneath the platen here. We are going to need a calibration device or reference that is traceable. In this case here, today we are going to be using a set of gauge blocks, and those are calibrated and they are traceable. They come with their own calibration certificate. This is valid for 1 year. This is the calibration gauge blocks. As you can see, they come in different thicknesses, and they need to cover the range of our displacement sensor at least 60%. Also, you need to have a different set so you can have different points. This is the calibration that we are going to be using today, and you could have also different references as long as they are traceable. Other people have used micrometers, or you can have digital dial gauge. As long as they are calibration grades and also they are traceable, then you can use your calibration reference to do your calibration for your displacement sensor that is underneath the platen here. Now that we have our calibration devices ready, which are the gauge blocks, and I explained it in the first part of this calibration procedure, step by step. The next step is our displacement sensor. We need to move the platen to a position that corresponds to the middle range, about the middle range of our displacement sensor. And to do that, we need to raise the platen. Depends on where the platen is located, but we need to raise it. That will correspond to a microstepper reading to about 800 to 900,000 steps, or in terms of counts reading or bit reading, we need to be about 40,000 counts. So what we're going to do, we're going to go to the menu, and in the menu we're going to go to position, which is number 2, and we're going to, in this case here, we're going to raise the platen, and we're going to look at the counts on the further right side, and we want to be about 800 to 900K. Don't pay attention to the readings here because we are doing the calibration now. So we're going to wait until the platen is about halfway, as I said before, and that will correspond to about 800 to 900K. That also will give us a lot of room to insert our gauge blocks underneath the platen so we can do our calibration. And we need to do at least 4 points to do our calibration for our displacement sensor. Right now we're waiting for the platen to move to reach about 850, 900K, and once we reach that, then we are ready to do the calibration of our displacement sensor. So now we're gonna wait, and we're about there, about 850, 860. I'm just gonna press any key. So now we are ready. As you can see, the sensor is underneath the platen here, and we got a lot of range here to insert our blocks underneath so we can do our calibration. Okay, we have our calibration devices, which are the gauge blocks. They are ready. Also, we have moved our platen to about halfway, which corresponded to about 850K in terms of micro steps. Now what we need to do is we are going to be using a software program that has built-in menus to do our calibration. Now you can use any software program that uses a displacement sensor to do your calibration, and once you do the calibration once using the software, then all you have to do is cut and paste it and put it in a different software if you have multiple software programs. In this case here, because it's a triaxial system, we are going to be using the triaxial software. Alternatively, you could be using a consolidation software or an unconfined compression software or the CBR software. So what we are going to do now, we are going to go to the computer and we are going to load our software. This happened to be our triaxial. So I'm going to the triaxial, I'm going to load a file. This happened to be a calibration file that was from the previous one. And then I'm going to go to Calibrate, my displacement. Right now I have dial gauges or dial reading. Those are the standard, the gauge blocks that I showed you. That was from the previous calibration. If there is any calibration data here, what I'll do, I'll zero this column and I click Calibrate, so everything is zero now. Also what I do is I click on the graph so I can see the progress of my calibration. This is my zero and this corresponds to, if I go to view system monitor, there's a displacement here that's about 42,456. That's what I said before, it's about halfway. The total count is 65,000. So I'm a little bit over half, so I can insert my gauge box. And if I click on the first row here and I do read, then the software automatically takes this value, which is live, and reads it and put it here. So next what I'm going to do is I'm going to be inserting the blocks, and that corresponds to each one of these readings, and do read, and I go to the process. I'm going to have 9 points in here all the way. The readings are in inches just because the gauge blocks are in inches, but they could be in any sets of units that you are comfortable with. Now we are ready to do our calibration for our displacement sensor. The platen has been moved out to about halfway to the middle range. We have our gauge blocks, they are ready. The software is open and we have the menu is open, is ready. We have all the gauge blocks that correspond all the way to 1 inch here, which is about 25.4 millimeters. And so the next time what I'm going to do, I am going to be handling these gauge blocks, and it's recommended that you use a rubber gloves. So I'm going to put my rubber gloves so I can handle my gauge blocks. So now what I'm going to do, I'm going to take my first gauge block, which corresponds to 0.0625, and it's written on it. Just make sure that you insert it in the correct way, which is the smooth way here. So I'm going to go underneath my platen and I will insert my first gauge block. So now the displacement sensor has moved down by the amount of the thickness of the gauge box, which is 0.0625. Now I'm going to go to the software here and I look at my dial reading, which is 0.0625 inches. That corresponds to my first gauge block. And what I'm going to do, I'm going to do read. So now it's going to read the displacement from what was 0, which was our reference. You notice here that the numbers are negative, so because we are doing the calibration in a descending order, so we can get a calibration factor that is positive. So I have 2 points now. I can do calibrate. Based on 2 points, we have the software automatically gives you the factor in inches or whatever millimeter per count. There's an offset, which is a theoretical offset, standard error, which is 0 here, and a correlation of 1, because this is a perfect line because of the 2 points that you see here. So the next one is I am going to remove my first gauge block and I am going to insert the next one. Next one is 0.1. And so now I have the next point. So I go back to my software and do read again. So now I have 3 points. Do calibrate. So I can see my calibration now is taking place. I have 3 points. Then again, I'm going to repeat the process. I'm going to remove my third point and put the next one, which is 0.125 underneath, and go back to the software to the same line and do read and calibrate so I can check what's going on. Again, I will remove my third point and put the next one. So my calibration is taking place. I am already on the fourth point. So my next one. While I'm doing this calibration, I want to make sure that there is no one bad point or something is not right, and I could tell in the graph if the point is completely off or the error is too big on each point. What you see here, so we have my next point, and while I'm keeping track if my correlation has to be at least 4 nines and my standard error as low as possible. I got my 8th point and my last point, which is 1 inch. So my calibration is done. I got all my points in. I got my calibration factor, I got my standard error, my correlation, this is the graph, and in order for this new calibration to take place, I just have to hit save. So when I look at my summary here on my displacement, this is the old one that was done in July 30th, and this is the calibration factor. When I hit save in my Calibrate displacement menu, then the software will automatically take this factor and this offset, put them in here and update the date when it was done. So this is our new calibration, and you do apply and you do OK, and we're done with the calibration of the displacement sensor.